Going to be about shifting and reflecting functions. And so you can go ahead and fill that in as your topic or objective. The essential question here is, how does the graph of f of x change when you add, subtract, or multiply its inputs and outputs? I'll say that one more time. How does the graph of f of x change when you add, subtract, or multiply its inputs and outputs? So we're talking about graphing, which is why I have this graph indicated over here. I'll try to make it a little bit bolder so that you can see it a little bit better. There it is. And so you're going to see in the Khan Academy exercises, you're going to see functions like this. This particular function is a cubic function, but you don't really need to know that. We're going to try to explore what happens when I mess with f of x a little bit and how it changes the graph. And so the first little question I want to answer is, how do you flip a function? And so the first thing I need to note is that if I want to take a function and I want to take something that looks like this and I want to flip it over so that it ends up looking like this, which means I flipped it. The parts that were up are now down, and the parts that were down are now up. I'm going to take f of x and I'm going to make it negative f of x. And so we can see that here. Watch when I type in negative f of x. It flips it totally over, so this point that was up here at positive 2 is now down at negative 2. This point that was at positive 0.6 is now here at negative 0.6. And this part that was going off into infinity upwards is now going down to infinity downwards. And so when you think about all that, if you want to flip a function, you have to multiply it by a negative. All right, so that's round one. And I might be able to make that a little bit more clear here. Let's try this. That's not very good. Here it is. That's negative f of x. Okay. How do you stretch a function? Stretch means, I'm going to put a star here, make it steeper. And that's make it steeper everywhere. And so what I want to do is I want to take a function that looks like, let's say like this, and I want to change it so that it becomes this. And so all I did was, you'll notice that each part of the graph has become steeper. And I'm going to write here multiply by a whole number. So an example is 3f of x. Sorry, my handwriting's terrible. 3f of x. So let's go ahead and look at that as an example here. I'll get rid of this guy. So if I take this red function and I want to turn it into something that is steeper, I can multiply f of x by a whole number. And so you'll notice that every step of the way now, this blue function is steeper than the red one. It's because I multiplied by a whole number. The next thing I'm going to look at is, how do you shrink a function? I'm going to put a star here. That means make it less steep. And so if I have a function that looks like this, I want to change it so that it ends up looking like this, so that it's less steep everywhere. And so in order to do that, I multiply by a fraction less than 1. And so example, I can take f of x and multiply it by 1/2 f of x, and it will make it half as steep everywhere. Again, let's look at our example here. If I want to take my red function and make it less steep everywhere, I'll take it and I'll multiply it by 1/2. Oops, I need to get out of that fraction. There you go. And so you'll notice that it's less steep everywhere. And so if I want to flip, it's a negative. If I want to make it steeper, multiply by a whole number. If I want to make it less steep, multiply by a fraction. All right, there's a second set of twists here. And I'm going to write, how do I shift up and down? To shift up and down, add or subtract to the outputs. And so, for example, I'll take f of x, and I want to shift its outputs up or down, so I'll just add 6 to it. And this will shift up 6. Okay? And so when I look at that in more detail, what you'll see is you'll have some function like this, and you're going to take it, and you're just going to shift it so that you take the exact same graph, and you're going to shift it up 1, 2, 3, 4, 5, 6. So it keeps the same shape, it just shifts up 6. Okay? If I want to shift down, it's just going to be f of x minus 3, say. And so the same thing's going to happen if I set up my axes and draw my graph again. If I have this function, if I want to shift it down 3, whoops, sorry, having a little technical difficulty here. Play nice, iPad. So I'm going to take the exact same graph, and I just shift it down 1, 2, 3 spaces. It's the same shape, it's just moved downward minus 3. All right, the last thing to think about is how do I shift left and right? And this is maybe the hardest one to think about. And so what I'm talking about is I want to take this function and I'm going to take that exact function and I just want to shift it to the right. And so I'm going to make a note here, shift right by 3. And the question is, how do you do that? I'm going to zoom in here, and I want to point out a couple of things. You don't have to write this particular part down. I just want you to listen really closely and maybe rewind and listen to it again if you need to. On this blue function, right here, it's giving me the output from this spot on the function, on the red function. So it's giving me the same output as if I were on the red function several spaces back. And so it's like the blue function is tricked into thinking that we're not at this input, but we're actually back here at this input. And so what that means is that to shift the function right, I need to trick the new function into thinking we're actually a few spaces behind. And so in order for that to happen, this is where you should write stuff down again. Shift right 3 is we're going to trick the function. We're going to change its input. So inside the parentheses, we're going to say, you know what? I don't want to look at x. I want to trick you into thinking we are 3 spaces behind right now. And that's what I mean by this. We're tricking the function into giving me the output from 3 spaces ago. To do that, you have to subtract from the input. And so if I want to shift left 3, which is going to take all of this stuff if I want to shift left 3, oops, just a moment here to try to shortcut. If I want to shift left 3, I'm going to take this blue function, and instead of shifting it to the right 3, I'm going to go 1, 2, 3 to the left. Now I have tricked the function into thinking when I'm here, I'm tricking it into thinking I'm actually over here. So that means I'm taking the input, I'm tricking it into thinking we're 3 spaces ahead. And so a shift left of 3 is f of x plus 3. I'll show you all those examples now. So if I do f of x plus 2, it just shifts the whole graph straight up. Minus 2 is going to shift it straight down. If I do f of x minus 2, it shifts it to the right. F of x plus 2 shifts it to the left. And so basically, for this set of problems, you just need to identify what's changed, and sometimes those things will be combined. So you might see a function that is like negative 1/3 f of x, which is both flipped and less steep. And so you have to recognize that it's going to have a fraction and a negative there in order to produce the new blue function. So good luck with it. Ask me questions if you need to. At this point, you should take a couple of minutes and try to write a summary to process this information so that you can be ready to perform well on